Hello students, today our topic is trigonometric functions. First of all, you should know what is trigonometric ratios. There are 6 trigonometric ratios. The 3 ratios are sine theta, cos theta and tan of theta. And the 3 are reciprocal of these 3 ratios, cosecant theta, secant theta and cot theta. So we can write sine theta as equal to 1 over cosecant theta, cos theta is equal to 1 over secant theta, and tan of theta is equal to 1 over cot theta. What are these ratios equals to? So if you have a triangle and we take right angle triangle with the one angle is 90 degree and we consider any angle is theta, so then the side which is opposite of the theta is opposite side, and the side which is next of theta is adjacent, and the side which is opposite of 90 degree is hypotenuse. So sine theta is actually equals to opposite over hypotenuse. Cos of theta is actually equals to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. In simple, we can remember that sine is SOH, which is sine equal opposite over hypotenuse, CAH, which shows cos adjacent over hypotenuse, and TOA, which shows tan equal opposite over adjacent. These symbols just to memorize these ratios. Same, you can know that cosecant will be the opposite of sine, so it will be hypotenuse over opposite, and secant will be hypotenuse over adjacent, and cot equal adjacent over opposite. As we know the trigonometric ratios, there are some trigonometric identities which you need to remember. So one is secant square plus cos square is equal to 1. 1 plus tan square is equal to secant square, and 1 plus cot square is equal to cosecant square. We'll use these trigonometric ratios to solve the questions. Let's go to the questions. Here we need to prove this question. So we'll take the left hand side to prove it, and in left hand side we have tan of x which is equal to sine theta over cos theta, and cot theta can be written as cos theta plus sine theta. And when we take the LCM of this, so cos theta sine theta, which will be sine square theta, because the denominator is cos theta, so the next number sine theta will be multiplied with the numerator, so sine square theta. In the other fraction you have sine theta on the denominator, so cos theta will be multiplied with the numerator, give you cos square theta. This is how we take the LCM. And numerator you can use the formula sine square plus cos square equal 1, so it will be 1 over cos theta plus sine theta. And now we can separate cos and sine, so 1 over cos, 1 over sine, and you know that the 1 over cos is secant and 1 over sine is cosecant. This is another question which we need to prove. So we take the left hand side and we write the tan of theta as sine over cos. So cos theta plus sine over cos sine theta. And then we take the LCM. We can see that the cos theta has 1 on the denominator. So cos theta is in the denominator, cos theta square plus sine square theta. And here you know that this identity is equal to 1. So 1 over cos theta, which is actually secant theta, that is actually your right hand side. Here is another question to prove that. If you notice that the left hand side have the cosecant secant somethings, and the right hand side also in the form of cosecant and secant. So all you have to do is we convert it into the simple ratios sine and cos. So 1 over sine theta plus sine theta over cos theta, 1 over cos theta. By taking the LCM, you can have sine theta cos square theta on the denominator, and you have on the numerator cos square theta plus sine square theta, which is again equals to 1. So it will be 1 over sine theta over cos square theta, and now separate. So 1 over sine theta is cosecant and 1 over cos square theta is secant square. Now there is another question which we need to prove. If you notice that the right hand side is in the form of tan square and cot square, which can be easily converted into sine and cos, and then we simply convert them into secant and cosecant. So tan square minus cot square, we take the right hand side and we write it as sine square over cos square minus cos square over sine square. And then simply take the LCM, and after taking the LCM we can have the numerator as sine 4 theta minus cos 4 theta. Sine 4 and cos 4 can be written as sine square of square and cos square of square, and denominator is the same, cos square sine square. As you know that a square minus b square is equal to a plus b and a minus b. So use this technique here. Have the square of sine square and cos square with the minus sign between, so we can write it as sine square minus cos square and sine square plus cos square. Sine square use as a and cos square use as b, and denominator is the same. So from the numerator you can check that sine square plus cos square, which is equal to 1. So you have the numerator is simply left sine square minus cos square, and the denominator is cos square sine square. You can separate each numerator term with the denominator term. So sine square separate with the denominator term cos square sine square, and same cos square separate with the denominator term cos square minus sine square. Same term would be cancelled out, and the left of terms will be write it as 1 over cos square minus 1 over sine square, which is simply converted into secant square minus cosecant square. In this question, you can clearly see that the both functions are look same, just the difference of sign. So we can use a formula, as we know, a plus b and a minus b, that is actually equals to a square minus b square. So we use the same thing here. It would be converted into secant square minus tan square. As we know the trigonometric identities, we know that 1 plus tan square theta is equal to secant square theta. So in the place of secant square theta, I will write 1 plus tan square theta, and minus tan square theta would be as it is, which can be cancelled out with the positive, and the left will be 1, which is your right hand side. Here you can see that the left hand side has cos square, but right hand side have the sine. We can remove the cos and convert into sine by using the trigonometric identity, which is sine square plus cos square is equal to 1, and cos square theta is equal to 1 minus sine square theta. So write 1 minus sine square theta in the place of cos square theta, and by simplification you can have 2 minus 2 sine square theta minus 1, which is equals to 1 minus 2 sine square theta. Here you can see that the left hand side have the cos square and sine square, but right hand side have the tan square. So we take the right hand side to prove the left hand side. That will be way easier to solve. So 1 minus tan square, 1 plus tan square. So tan square will be converted into sine square over cos square. Denominator will be same. And now we'll take the LCM of numerator and denominator both terms separately. So for the numerator, it will be cos square as a LCM, and you will have cos square minus sine square. And same thing we do on the denominator. So cos square, it will be cos square plus sine square. And the denominator both will be cancelled out. On the numerator, you will have cos square theta minus sine square theta, and denominator you use the trigonometric identity, which is equals to 1, which is actually the right hand side. In this question, you can see that again on the right hand side we have cot. So we take the right hand side and convert the cot into cos over sine, and use the same thing. We take the LCM of the numerator and denominator terms separately. And after taking the LCM, you can see that the denominator of the both term is the same, which can be cancelled out. And numerator is left as cos square theta minus sine square theta, and denominator with the positive, which is actually the right hand side. In this question, if you notice that the left hand side have the cot of theta, so we can convert it into cos over sine. So we take the left hand side and take the LCM. In the LCM, you will have denominator with sine theta 1 plus cos theta, and denominator will become sine square theta plus cos theta 1 plus cos theta. And the sine square plus cos theta plus cos square theta, and denominator will be sine theta and 1 plus cos theta. And then you can see that numerator will, which is have sine square plus cos square, we can combine it, which will be converted into 1 later on, and write the other terms as it is. And here it will be 1 plus cos theta, and denominator sine 1 plus cos theta, and 1 plus cos theta is the same, can be cancelled out, and you left 1 over sine theta, which is actually cosecant theta. In this question, we can see that left hand side have the chord terms, so we can take the left hand side and convert chord square, cos square over sine square, minus 1 plus cos square over sine square. So sine square is on the denominator, cos square minus sine square, and same we take the LCM of the denominator term, and having the same denominator can be cancelled out, and you left cos square minus sine square, and denominator cos square plus sine square will be 1. So now it's time to remove the sine square from here, because the right hand side only have the cos square. So as we know that the sine square plus cos square is equal to 1, and the cos square, because we want the term in the form of cos only, so we find the sine square value from here, which is 1 minus cos square, and place this value in the place of sine square. So cos square minus 1 minus cos square, and which will be later converted into the positive sign after open the bracket, and then you have 2 cos square minus 1. That's your right hand side. In this question, instead of taking left hand side, we'll take the right hand side, because right hand side have cosecant and cot, which will be converted into cos and sine easily. So cosecant is equal to 1 over sine, and cot, you know, the cos over sine, and take the LCM. When we take the LCM, denominator is same, which will be sine of theta, and because of the whole square on the above, it will be sine square theta, and numerator will have the same denominator, so numerator will be as it is, 1 plus cos theta, but the square on the top of this, and sine square will be converted into 1 minus cos square. Now in the denominator we use the formula of a square minus b square again, which can be write as 1 square minus cos square, and you know that a square minus b square is actually equals to a plus b and a minus b, so we can write it as 1 minus cos theta and 1 plus cos theta, and the same term would be cancelled out, and you left as 1 plus cos theta, 1 minus cos theta. That is actually your left hand side, so it's proved. You can try the another question, which is secant theta minus tan square theta is equal to 1 minus c sine theta over 1 plus sine theta. It will be solved the same way as we did here. And in this question, we take the left hand side and convert tan into sine over cos, and then later on we take the LCM of the denominator term, which will be cos square plus sine square over cos square. And if you notice that the denominator of the both is the same, just the difference of power, so one cos will be cancelled with the one cos, and one cos is left as it is, which will be go to the numerator and multiply with the numerator term. So 2 sine theta cos theta you have, which is your right hand side. In this question, you can take any of the side first and try to convert into the other side by using the rationalization. So I will take left hand side. So I will multiply its conjugate. So 1 plus sine theta over 1 plus sine theta, multiply and divide it. Numerator terms will multiply and same denominator terms will multiply with the denominators. Numerator will be used as a minus b and a plus b, which is a square minus b square, and denominator as it is. As we know that 1 minus sine square theta will be converted into cos square theta using that trigonometric identity, and one cos is cancelled out, and you left as cos over 1 plus sine of theta, which is your right hand side. In this question, left hand side is in the form of fraction having tan and secant, so we can take the left hand side first and try to prove it to the right hand side. So here I will combine tan theta plus secant theta and try to rationalize. But we will take the rationalization of a numerator term. Numerator term is tan theta plus secant theta with minus 1. So to rationalize this, we will take the numerator term, like one term will be considered as tan theta plus secant theta, and second term is considered as 1. So it will be plus 1 multiply with the numerator and denominator both. And in the numerator, you have one term is tan theta plus secant theta, and the second term will be 1. So it will be converted as a square minus b square. Denominator terms will multiply it as it is. But I will rearrange the denominator term. So I will write tan of theta with 1 and secant theta is separate, so that we can simplify it later on. So tan theta plus 1 minus secant theta, this is the first term, and second denominator same as tan theta plus 1 plus secant theta. Why I did this? So that we can have the denominator same, having only the positive and negative sign different, which can be later on converted into a square minus b square form. So open the formula on the numerator, tan square plus secant square plus 2 tan theta secant theta minus 1, and denominator is, as I told you, that we have first term minus, it looks like a minus b and a plus b, where a is used as tan theta plus 1 and b used as secant theta. It will be tan theta plus 1 square minus secant square theta. And in the numerator term, I will combine secant square minus 1, because we know that 1 plus tan square theta is equal to secant square theta, and tan square theta is actually secant square theta minus 1. So I will combine it and write it as tan square theta. And you have plus 2 tan theta secant theta. In the denominator, we will open the square. So tan square theta plus 1 plus 2 tan theta minus secant square theta. So in the numerator, we combine the square. So 2 tan square plus 2 tan theta plus secant theta. And what about the denominator? In the denominator, you have tan square theta plus 1, which is actually equal to secant square theta, and secant square theta, and the remaining term as it is. So positive and negative will be cancelled out. By taking the common the numerator, you have 2 tan theta, which is tan theta plus secant theta, and denominator 2 tan theta. Same terms will be cancelled out, and you left only tan theta plus secant theta, which is right hand side. In this question, we'll simplify the both so that we can have left hand side and right hand side equal. But remember, whichever the side you take, we will rationalize only the one term will be in the form of plus and minus. Just like here, left hand side, so rationalize only the first term and second term as it is. So 1 over cosecant minus cot, so rationalize it cosecant theta plus cot theta, and cosecant theta plus cot theta, multiply and divide. And 1 over sine as it is. So we simplify, and numerator and denominators multiply, and next term is 1 over sine, which is actually cosecant theta. So as we know that 1 plus cot square is equal to cosecant square, which is the third trigonometric identity. So we can find the value of 1, which is cosecant square minus cot square. In the place of cosecant square minus cot square, we will write 1. So it will be cosecant theta plus cot theta over 1 minus cosecant theta, and cosecant theta plus cot theta minus cosecant theta, both will be cancelled and you left cot theta. Okay, so now take the right hand side. We'll do same as the left hand side. So 1 over sine, and do the rationalization only on the part of 1 over cosecant theta plus cot theta. And 1 over sine is as it is, and other term by multiplying numerator and denominator, and same thing will be happen as we did in the left hand side. Apply the formula which converted into 1, and 1 over sine converted into cosecant. So cosecant minus cosecant plus cot, because of the minus outside will be multiplied, so you left as cot of theta. So you can see that left hand side and right hand side is same, so the question is proved. Here the question is in the form of cube. So we use the cube formula, as we know that a cube minus b cube is equals to a minus b, a square plus b square plus ab. So use that formula, sine theta minus cos theta, and sine square theta plus cos square theta minus sine theta cos theta. And you know that the square of sine and plus cos is equal to 1. So this will be simply give you right hand side easily. You can try this question and prove it the both sides using the cube formula. And one more question, this is also use the cube formula. So when you solve it, you can easily get these sides equal. Thank you so much.